Hello and good morning, everybody. Once again, uh, today we will discuss about a very simple uh, thing that is uh, we usually face difficulty that some quantities are in one category and some are the other categories, and that actually is about you call scalars and vectors. So first thing that we are going to talk about today is what are the scalars and what are the vectors. Before I talk about vector and scalar, I just need to review one thing, that whenever in physics we talk about measurements, we need any measurement with a numerical value attached with a unit. Like if I ask you for your height, so you can ask me 170 centimeter, or you might ask me 5 feet 6 inches, uh, etc. So forever, whatever the quantity you are telling, you need a numerical value along with the unit. And in physics, we call this numerical value plus the unit as the magnitude. We call it magnitude. So now coming back to the point, whenever we are concerned with quantities like the mass, like the time, like temperature, so these quantities only need magnitudes for their complete description. They don't need any direction. They need only magnitude. So we call them a directionless quantity. So any scalar quantity is a quantity that need only magnitude for its complete understanding, but no direction. Like I said, mass, time, temperature, all are the scalar quantities. So I can show you that this mass is measured in kilograms. So we can say something 5 kilogram or 50 kilogram or 10 kilogram. When you talk about the time, it may be 10 second or 15 second, or it may be 1 hour, or it may be 1 year, etc. Temperature might be 290 Kelvin, temperature might be 70 degrees Celsius. So whatever it is, we don't need to tell that it is 70 degrees Celsius toward east, west, north, south. So these quantities which require only the magnitude for their complete description are called scalar. So I can say that uh, these require only magnitude but not the unit. Sorry, not the direction. I'm so sorry, not the direction. So direction is not required. So not directional quantities. So on the other hand, when we talk about the quantities which are vectors, like when you talk about displacement, when you talk about velocity, displacement, velocity, you say weight or force, these type of quantities, whenever we are concerned, what we need a 5 Newton force. But 5 Newton force, in which direction? You might have to say it is to the right, to the left, or some other direction, to up, to down. When you talk about weight of 100 Newton, so it is understood that weight is always toward the ground, so toward the earth's center. So it has a direction that it is always toward the ground. When you talk about the velocity of an object, that is 50 meter per second, we need to mention that it is to the north, east, west, south, or some other thing. So displacement is also same, that it is 20 meter to the east or to the west. So all of these quantities which require direction are called vector quantities. So we can see that these are directional. We need the direction for them, and those quantities which doesn't require any direction are scalar quantities. So I can just simply say that a vector is a quantity that has magnitude and the direction. So whenever we have magnitude only, it is scalar. So I can also say that vector is a quantity which is a scalar plus direction. So any scalar means any magnitude containing quantity that will have a numerical value, a unit, and direction in vector. So in third way, I can write it is uh, a number associated with a unit, number plus unit, and the direction. If these three things are here, like 5 is a number, Newton is a unit, and to the left is direction, then it will be a vector quantity. I hope you got the idea of the uh, difference between scalars and vector.